All right, this is our study guide for assessment 7.0, and 7.0 says verify that a point lies on a plane, that a point lies on a line, given an equation of the line, and derive linear equations by using the point slope formula. So number one, without graphing, explain whether the point 0, 1 is on the graph of y equals 4x plus 1. So is the point 0, 1 on the graph of y equals 4x plus 1? How do we know for sure? Well, we could graph this and we could actually look at it, but the most accurate way is algebraically. So if we make a function table and we make an x and a y, of course we know that in every ordered pair the first value is the x value and the second value is the y value. So if we make x 0 in our function table and we make y 1 in our function table and we plug both of these values in, let's see what happens. Y is 1. Y is 1, so instead of y I'm going to write 1 equals 4 times x. What's our x value? It's 0 plus 1. Okay, I multiply before I add, so if I multiply this I get 0. Well, if that's 0, then doesn't this just equal 1 on the right hand side? So this 0 plus 1 equals 1, and I have a 1 on the other side. Is this a true statement? Does 1 equal 1? You bet it does. So guess what? If this is true, then that means when x is 0 and y is 1, those values make this equation true. Well, if these values make this equation true, then this point is on the graph of this equation. And if we were to graph it, if I were to begin graphing at positive 1 on the y-axis and do a slope of 4, positive 1 on the y-axis, and do a slope of 1, 2, 3, 4 over 1, 1, 2, 3, 4 over 1. There's my straight line. Continues in both directions. Is the point 0, 1 on that line? Well, of course it is. That's my y-intercept, isn't it? Duh. Okay. Let's look at number 2. Without graphing, explain whether the point 2, 3 is on the graph of 4x plus 2y equals 12. So the point that we're going to plug in is 2, 3, 2, 3, x is 2, y is 3. Now look at this. Last time our equation was in slope-intercept form, y equals mx plus b. Now it's in standard form, 4x plus 2y equals 12. It's a completely different equation, and it's in a different form. Does it matter that this is in standard form if we're going to plug in x and y? Absolutely not. So instead of x, we're going to plug in 2. So 4 times 2 plus 2 times, and instead of y, we're going to plug in 3 equals 12. 4 times 2 is 8. 2 times 3 is 6. And that's supposed to equal 12. Well, what's 8 plus 6? Oh, it's 14. Does 14 equal 12? Nope. So this is false. So what that tells me is when x is 2 and y is 3, it does not make this equation true. It does not satisfy this equation. So this point 2, 3 will absolutely not be on the graph of this equation because it doesn't make it true. If it can't make it true, then it can't be on the line. Neener, neener, neener. Number 3. Write an equation in point slope form for the line that has a slope of 1/2 and contains the point 8, 2. So the slope is a half, and it contains the point 8, 2. So we're going to look at this and look at this. What do we have here? Let's see. We have a point and we have a slope. And the directions say to put it in point slope form. Well, that's easy. Do you know what point slope form is? I do. It's y minus y sub 1 equals m times the quantity x minus x sub 1. M is my slope, and this is x1, y1. Those points are going to go here and here, and this x and y just stay x and y. So the smart thing to do here is to label your point x1, y1. Remember, we have a point and we have the slope, so we can easily plug that into the point slope form of an equation, which is this right here. So this y stays y. Be careful, we're going to subtract y sub 1, which is 2, and that equals m, which is our slope, which is 1/2, times the quantity. This x just stays plain old x, and we're going to subtract x sub 1, which is 8. If they have that nicely labeled, all you got to do is plug your values into here and watch your subtraction signs, and you're good to go. Now, this problem said to put it in point slope form. Well, we just did. Guess what? We're done. We just put it in point slope form, and that's all they asked us to do. Cool. Let's look at number 4. Write an equation in slope-intercept form. Slope-intercept form is y equals mx plus b. Write an equation in slope-intercept form of the line with a slope of 4 that contains the point -3, -4. Okay? And we're going to put it in slope-intercept form. So it has a slope of 4, has the point of -3, -4, and we want it in slope-intercept form. Well, I'm not ready to put it into slope-intercept form. I know what m is, but I don't know what my y-intercept is. I have this other point that's on the line, but I don't know what the y-intercept is. All I have is this point and a slope. Whoa, what did I just say? We have this point and a slope. Well, then let's put it in point slope form. Y minus y sub 1 equals m times the quantity x minus x sub 1. We know what our slope is because we were given that, and that's going to go here. Now, we're going to label this x sub 1 and y sub 1. So this y stays plain old y. We're going to subtract y sub 1. Look, y sub 1 is already negative, so we're going to subtract something that's already negative. We're going to subtract a -4, and that's going to equal m, our slope, which is, where's our slope? 4. So it's going to equal 4 times the quantity, plain old x, minus x sub 1. Well, look, x sub 1 is already negative. So we're going to subtract a number that's already negative. We're going to subtract -3. Okay, it's in point slope form, but the problem said to put it in slope intercept form. Well, look, this isn't a far stretch from what we have. The first thing I'm going to do is get rid of all these negatives. They're driving me nuts. And I know that when I subtract a negative, it's the same thing as adding a positive. Same thing here. If I'm subtracting a negative, it's the same thing as adding a positive. Remember my story of me and Mrs. Williams? I was feeling all negative, and she took away my negatives, and I instantly became more positive. So I'm going to rewrite this. Y plus 4 equals 4 times the quantity x plus 3. Now I'm going to do my distributive property and make my parentheses disappear, and I'm going to get 4x plus 12. And over here I have y plus 4. Oh, look, I'm almost there. Y equals mx plus b. If I want to get y alone, I got to get rid of that positive 4 by using a negative 4 here and a negative 4 here. So y equals 4x, and then right here, if I have 12 positives and 4 negatives, I have more positives than negatives. I have 8 extra positives left over. Hey, this equation came about from being given the point and the slope for this line. We started with point and slope. We put it in point-slope form. After we did that, we got it into slope-intercept form. So what I'm thinking is, if this is the equation of the line, when I graph this line, shouldn't this point be on it? It better. It better. Let's see. So if I'm going to graph this, I'm going to begin at positive 8 on the y-axis. Positive 1, 2, 3, 4, 5, 6, 7, positive 8. And my slope is 4, which is 4 over 1. 4 over 1. Let's see, my point was negative 3, negative 4, so I better go back the other way and go negative 4 and negative 1, and negative 4 and negative 1, and negative 4 and negative 1. That's my nice straight line of points, isn't it? And look, the point negative 1, 2, 3, negative 1, 2, 3, 4 is smack dab on that line, that nice straight line right here. If I had one more hand, I'd draw it with my ruler, but I only have 2 hands and I'm holding a camera, so you're going to have to use your imagination. All right, that's number 4. Let's look at number 5. Write an equation in point-slope form. Okay, what's point-slope form again? Y minus y sub 1 equals m times the quantity x minus x sub 1. That's point-slope form for the line that has a slope of 2 and contains the point negative 1, 4. So let me get this right. We have this point and we have this slope, and they want us to put it in point-slope form. It's so stinking easy. This point, this slope, point-slope form. This is x1, y1. This is my slope, m. My slope is 2. So I'm going to put y minus y sub 1. Well, y sub 1 is 4 equals m, which is 2, times the quantity x minus x sub 1, which is already negative, so we're going to subtract a negative 1. Look at this. We're subtracting a negative. I'm going to say that we're adding a positive, and I'm going to rewrite this because I want to get rid of all those signs. They confuse me. So this is just x plus 1, and this is y minus 4. This 2 was part of my slope over here. I don't want to confuse that. So I'm going to do my distributive property, and I'm going to get y minus 4 equals 2x plus 2. I want y alone, so I'm going to add 4 to both sides. I'm such a silly knucklehead. This said put it in point-slope form, so I did. And then I kept going, but all I needed to do was put it in point-slope form, and we did that right here. Y minus y sub 1 equals m times x minus x sub 1. We did that already. We're done. This was our answer way back here. Silly. What a goofball. Okay, number 6. Write an equation in slope-intercept form for a line that passes through 4, negative 5 with a slope of 1/2. 4, negative 5 with a slope of 1/2. Okay, so let's see, what form? Slope-intercept form. So we want this to look like this when we're done. Slope-intercept form. We are given a point, which is 4, negative 5, and we are given the slope, which is 1/2. Okay, do we have enough information to just put this information into here? Let's see, we have a point and the slope. That's enough to put it into point-slope form. This is slope-intercept. I'm not quite ready for slope-intercept, but I'm ready for point-slope. Y minus y sub 1 equals m times the quantity x minus x sub 1. I'm going to label this point 1, x1, and y1. Try this in a different pen. x1 and y1. And there's my slope. So y, plain old y, minus y sub 1, which is already negative. So I'm going to subtract a number that's already negative, and that equals m, which is my slope, which is 1/2, times the quantity, plain old x, minus x sub 1. Well, x sub 1 is 4. Now remember, this one has to be in slope-intercept form when we're done, and we just put it in point-slope form. So now we're going to simplify all this. We're going to do our distributive property here, and we're going to get 1/2 x. Now, 1/2 times negative 4. A positive times a negative is a negative, and 1/2 times 4. If you have a half 4 times, don't 2 halves make a whole? So if 2 halves make 1 whole, 4 halves make 2 wholes. And since it's a positive times a negative, it's negative 2. Oh, look over here. We were subtracting a negative. We better add a positive. So this is y plus 5 now, isn't it? And if I want to get my y alone, I'm going to subtract 5 from both sides. And I'm going to get y equals 1/2 x minus 7. Because 2 negatives and 5 negatives give you 7 negatives.